Alrighty, ladies and gentlemen, I'm here with Mr. Thornley, the one and only Mr. Thornley, recording the 2.4 Congruent Supplements and Complements.
Woo! 2.4 Supplements and Complements!
There are other classrooms learning at this time, but Mr. Thornley don't care. He plays by his own rules. Man's a rebel. Rebel without a cause. So let's talk about some comps and supps, shall we, and see if we can come to some dope conclusions, if you will. Let's say I've got angle A is complementary to angle B. And let's say angle C also happens to be comp to angle B. What could we possibly conclude if both A and C are complementary to the same angle? Well, some of you might already have a great idea as to what's going on, but I'm gonna toss some numbers in here for fun. You know, because sometimes it's nice having little numbers. Let's say angle B is 20 degrees, and that would mean angle B over here is also 20 degrees. What's angle A going to equal if they're complementary? Mr. Thornley, 20 plus what gives me 90?
Ooh, 70.
You the man, Thorn Dog. And I believe that would apply here because the rules of mathematics still apply. 20 plus 70 is 90. Oh my goodness. What do you notice about A and C? Angle A is congruent to angle C. That was awesome.
Wait, I got something for you.
Hold up. He's got something. So let's move on to another scenario. Let's say I've got angle A. Once again, it's complementary. Little Zeppelin in the background here from the Thorn Dog. Getting the let out. Woo! And let's say angle D is complementary to angle C. But I'm going to throw a third little tidbit in here for you. Angle B is congruent to angle C. Woo! Woo! So you might get an idea going here yourself, but I'm once again going to throw some numbers. Let's say that angle B is 30 degrees. So this angle B over here is obviously 30. And C would then be 30 since they are congruent to each other. So I can pop that over here. Ooh. Angle A is complementary to B, which is 30. So angle A is 60. Same logic for D. Oh, snap. Looks like we've got A and D congruent. So let's put this into some math words here, a little theorem action, shall we? That first scenario, we had two angles complementary to the same angle, and then they were congruent. So angles comp to same angle are congruent. And in the second scenario, we had two angles that were complementary to congruent angles, and they ended up being congruent. Angles comp to congruent angles are congruent. Woo! Beautiful. And there are a few different ways of writing this. Some people say comps of the same angle are congruent, or comps of congruent angles are congruent. You know, either way is cool. And this will also apply to supplements, if you know what's up. All right, so I could just replace comp with sup, and it is also true. Let's apply it. And when I say apply it, I mean in a totally relevant, real-life application of two-column proofs. You know, because one day you're going to be on the streets, some person's going to come up to you and be like, yo, if you know how to do this proof, I will introduce you to T-Pain, and you're going to know how to do it, all right? That's where this comes into real life, children. Well, just like that. Perfect. Wonderful. All right, so let's say I've got AD is perpendicular to AB. I know that we've got right angles. And I've got AC is perpendicular to AE. Ooh, got another right angle. And I want to prove that angle 1 is congruent to angle 3. I think I've got an idea of how to go about this. So with right angles equal how many degrees? Ooh, 90 degrees, right? And then if you got two angles that add to 90 degrees, what does that mean? They are complementary. So I'm thinking here that we've got angle 1. We could show that angle 1 is complementary to angle 2, and we got angle 3 is comp to angle 2 as well, right? Since these guys add up to 90, and these guys add up to 90. Ooh! 1 and 3 are complementary to the same angle. What does that tell me about 1 and 3? My goodness. They are congruent. Let's write it up. Let's write it up, Mr. Thornley.
great.
Oh, it sounds wonderful. I'm going to give myself a little more space. All righty. So we've got our first one is our given. And this thing's a little difficult to write on. I'm just going to pop an arrow down there for us. Ain't nobody got time to write out the whole given. It's crazy. I want to use my brain for math, right? Not just jotting things down. I want to be thinking. Okay, so I got perpendicularity. Now, sometimes some people like you to write that it's a right angle, then it's 90 degrees. I'm cool with perpendicular, meaning a right angle or 90 degrees, because I'm flexible like that, and super cool. Not everybody's like that, so you be happy that I'm cool like that. So we got angle BAD equals 90 degrees, and I've got angle CAE also equals 90 degrees. Definition: perpendicular. Why did I choose 90 degrees rather than saying right angles? Well, you may remember that the definition of complementary means that they add to 90, not a right angle, and our reason for that is because those angles don't necessarily have to be adjacent to each other, next to each other, right? So they won't always form a right angle, but they will add to 90 degrees if they're complementary. Okay, so I can say that angle 1 is comp to angle 2, and I've got angle 3 is comp to angle 2. And I can put that in the same step because they use the same reason, and one doesn't depend on the other. So one of them can happen before the other, or it could be switched around, and it's no big deal, right? If one depended on the other to happen, then you have to split it up. Alrighty, so I've got two angles. 1 and 3 are complementary to the same angle. Oh boy, my new theorem could show that those are congruent. Comps of congruent, oh, no, same angle, oh my goodness. Comps to the same angle are congruent, or angles comp to the same angle are congruent, however you'd like to word that. I think I worded this a little bit differently than I did in the previous page, but they get the same point across. Awesome. Alrighty, another example here. We've got some interesting notation happening here that is not correct. This is an error of the import. Those should be rays right here, okay? So that should be a ray, and that should be a ray. Cool? Awesome. Sometimes that happens when you go from PowerPoint to this app that I'm using. It's not always perfect, but it's pretty close. All right. So I've got angle 1 is comp to angle 4, 2 is comp to angle 3, and I've got that RT bisects angle SRV. So I know with bisecting, that would make these two angles congruent. 3 and 4 are going to end up being congruent when I bisect angle SRV. Okay. Now, it can be helpful to sometimes jot down some notes about complementary. We won't do that in this video. You'll actually see it in a future video because I can see into the future and I know what's going to happen. But I've got that angle 1 is complementary to 4 and 2 is complementary to 3. And I just said that I can prove that these two are congruent by definition of bisect. So I've got two angles, 1 and 2, are complementary to congruent angles. Pretty darn sure we got an awesome new theorem that can tell us that those guys are congruent. So if I can prove that 1 and 2 are congruent, I could probably say that TR bisects angle STV, right? Because it creates two new congruent angles. Heck yeah. Look at that. We're ready to write this bad boy up. Aren't we, Mr. Thornley?
Sounds fantastic.
He says it sounds fantastic. And I would agree that it sounds fantastic. I mean, nothing's more applicable than two-column proofs to your everyday lives. You know? Say you're at a job interview. Hey, bro, we're almost going to hire you.
Really?
Yeah. But could you do this two-column proof?
Oh, yeah, I paid attention in my geometry honors class. Oh,
Heck yeah, you did.
Oh, heck yeah, I could do
Yeah,
that.
yeah, perfect.
Yeah.
America.
Yeah.
Woo! All right, let's continue. So I think the first thing there, let's say that angle 3 is congruent to angle 4 by the definition of bisect. So now I've got angle 1 congruent to angle 2 because our two angles are complementary congruent angles. So comps of congruent angles are congruent, or angles that are complementary to congruent angles are congruent. Awesome. Step 4. Woo. Well, if 1 and 2 are congruent to each other, I'm pretty darn sure that TR bisects angle STV by our definition of bisect. And in that case, it would actually be, the converse of that definition that we used prior, okay? But I'm not going to make you remember if it's the converse or the initial one, because honestly, I don't even remember which one it is. But, it's more about, do you know how to use that definition and also apply the converse of that definition? And I think we just showed that right here. You know what I'm saying? America, freedom, rock and roll. All right, here we got not a proof. Nice little break from the proofs. Not that you need a break from proofs. Proofs are awesome. It says angle PQR is sup to angle QRS, and QRS is sup to TWX. And then we got those two algebraic expressions associated with the two angle measures. Awesome. And we want to figure out what the measure is of angle QRS. Well, right now I've got angle PQR and TWX supplementary to the same angle. My goodness, I think that means that PQR and TWX are congruent, and it just so happens that those are the two angles that you know something about as far as an algebraic expression. So if they are congruent, I can set them equal to each other because it's awesome. Right? They're congruent, they have equal measure. That is why, not just because it's awesome, but they're congruent. All right, so I'm going to solve this thing. So we got 3x, if I subtract the 2x over, equals 78. So I divide by 3. 78 divided by 3, I believe, is 26. As long as my calculator in my brain is working properly. Is that my final answer? Heck no, it's not my final answer. I need to figure out the other portion. Yes, I need to answer the question, which is the measure of angle QRS. Okay. Well, TWX is supplementary to QRS from our given. So if I were to plug in 26 to TWX, because I actually know something about that, what would I get? Well, 2 times 26 is 52 plus 30 equals 82 degrees. That's TWX, and QRS is supplementary to it. So I'm going to come over here where I've got some room. 180 minus 82, that gives me 98 degrees. My favorite, that'd be either a late 90s, early 2000s band with Nick Lachey, right? He's the man. So yeah, there we go, 98 degrees for our final answer. Make sure that you answer it. Answer that question fully, not just solve for x, not just get one of the angles that's easy to find. Answer it fully. YOLO, America, rock and roll. All right, make sure you children get your H-dubs done and get ready for that quiz tomorrow over 2-1 to 2-4, because it's so much fun to show me what you know. I know you guys love that. I know you love the stress of an assessment. You have something to look forward to tomorrow. Great.